Course 3, Industrial Processing, Food Processing Technologies and Automation. Good morning, everyone. Welcome to this practical training on applying storage protocols effectively. In the previous sessions, we learned why storage matters and what conditions are optimal for different products. Today, we are going to put that knowledge into action. We will learn how to develop a storage specification for a product, how to monitor storage conditions daily, what to do when something goes wrong, and how to measure whether our efforts are actually working. By the end of these 30 minutes, you will have the tools and understanding to manage storage in a way that keeps products safe, maintains quality, and wastes nothing. This is practical, hands-on learning. Let's begin. This module delivers an in-depth understanding of key food processing methods, exploring their influence on product quality, safety, and sustainability. Learners will acquire knowledge of classical and emerging processing technologies, examine their impact on nutritional and sensory food attributes, evaluate safety considerations including microbial and chemical hazards, and discuss sustainability implications such as energy use and waste reduction. This content prepares learners to critically assess processing choices within modern food systems. After completion, learners will be able to apply appropriate storage protocols and best practices to ensure freshness, food safety, and minimize waste. Assess the effectiveness of storage conditions. Think of storage control like a pyramid. The foundation, the most important layer, is prevention. We invest in good refrigeration equipment, we make sure it is maintained, we verify that products are packaged correctly with sealed, undamaged packaging, and we keep the storage environment clean and organized. Prevention is always cheaper than dealing with problems later. The second layer is monitoring. We take daily temperature readings, we look at the products, we check for any signs of mold or off odors. We know what normal looks like so we can spot abnormal. Monitoring tells us whether our preventive controls are working and gives us early warning if something is starting to go wrong. The third layer is corrective action. If our monitoring finds a problem, maybe the cold room temperature has drifted up, or we smell something off in the product, we act immediately. We fix the equipment, we quarantine the product to prevent it reaching customers, we investigate what went wrong. These three layers work together. Prevention stops most problems before they start. Monitoring catches what prevention missed, and corrective action minimizes the damage when something slips through. A storage specification is your map. Without it, different people on your team might store the same product in different ways, and you have inconsistency and problems. With it, everyone knows exactly what is required. When you write a storage specification, you are thinking through the product's vulnerabilities. If it is fresh produce, you think, what temperature stops bacterial growth but preserves freshness? What humidity prevents wilting? Do I need to protect it from light? If it is a dry powder, you think, what humidity prevents caking? Does it need air circulation to prevent mold? This thinking process and the resulting written document becomes your standard. You use it for training new staff. You use it for monitoring. Is the cold room at the right temperature? Is the humidity right? You use it for deciding whether to accept or reject a product, and it becomes your defense if there is ever a quality issue or a regulatory inspection. You can show the inspector, here is our specification for this product, and here is our evidence that we followed it. Here is your daily monitoring form. It looks simple, but it is critical. Every day, at least twice, morning and evening, someone goes to the vegetable cold room with a calibrated thermometer and records the temperature and humidity. Why calibrated? Because you want to know the real temperature, not what a drifted instrument tells you. The thermometer should be placed at the cold spot, usually a top shelf where cold air has risen and is warmest, which is actually where the product is most vulnerable. You record the exact temperature, the humidity, which thermometer you used, and your initials. If the temperature is within spec, 0 to 4 degrees, you note normal range and move on. If it is out of spec, say 5.8 degrees as in this example, that is an alarm. You stop using product from that room, you alert your supervisor, and you investigate. Is the compressor running? Is the door stuck open? Has something failed? You document everything. This form is your proof, months later, that you were monitoring consistently and that you responded when something went wrong. Recording procedure, check daily. Morning, 8 o'clock, and evening, 6 o'clock, minimum. Use calibrated thermometer. Verify calibration certificate is current, annually minimum. Record exact location. Position thermometer at cold spot, where it is warmest in the room, typically upper shelf. Record temperature and humidity, both in degrees Celsius and %RH. Note thermometer ID, so you can track individual instruments. Sign and initial. Take responsibility for the reading. Add notes, normal range, or specific observations if out of spec. Corrective action. If out of spec, stop use of product. Alert supervisor. Investigate cause. In addition to temperature monitoring, you also need to look at the product itself. At least once a week, or more often if there is a concern, take a sample from your storage and do a sensory check. Look at the appearance. Are the leaves green and vibrant? Or are they yellowing or browning? Some yellowing on day 7 is normal aging. More than 10% browning and the product is rejected. Smell them. They should smell like fresh green leaves. If they smell sour or fermented, that indicates microbial spoilage, and they are rejected. If they smell musty, that suggests mold, and they are rejected. Feel them. The leaves should be crisp and firm. If they are wilted despite being stored at high humidity, something went wrong. Either the humidity control failed or the product arrived already stressed from the farm. If they are slimy to the touch, that is bacterial slime, and they are definitely rejected. These sensory checks are your early warning system. By the time you wait for a microbiology test result, it is too late. The product is already in the market or already spoiled. Your senses are fast and reliable. Scenario. At morning check, temperature in vegetable cold room A is 6.2 degrees Celsius. Spec 0 to 4 degrees Celsius. Immediate actions. Do not send any product to packing. Segregate what is already packed. Alert supervisor and maintenance immediately. Investigate. Is compressor running? Is door stuck open? Is thermostat set correctly? Assessment. If compressor is not running, repair, restart. Recheck temperature after 30 minutes of operation. If the temperature is now back to 2 degrees Celsius, assess the risk. How long was it warm? Was it 1 hour or 8 hours? Decision. Product disposition. If temperature was high for 2 hours and outside temperature was 15 degrees Celsius, product may be acceptable. Record the incident and continue monitoring closely. If temperature was high for 4 hours or outside temperature was high, conduct shelf life study or discard product. Risk too high for ready to eat. Documentation. Record date, time, temperature reading, cause, compressor failure, duration of excursion, corrective action taken, product disposition, supervisor approval. Let me walk you through 2 realistic failure scenarios and how to respond. Scenario 1. Temperature excursion. You arrive at the cold room one morning and the thermometer reads 6.2 degrees. Your spec is 0 to 4 degrees. Your heart sinks because you know that warm temperature accelerates bacterial growth. What do? First, you stop the line. Do not send product out until you understand what is wrong. You alert your supervisor and maintenance immediately. You investigate. Is the compressor running? You can hear it or check the control panel. Is the door stuck open? Is the thermostat set correctly? Usually, you find the problem. Maybe the compressor failed. Maybe a door was left propped open. You fix it. If it is just a quick fix and the temperature recovers within an hour or 2, the product may still be acceptable. You document it and keep a close eye on the batch. If the temperature was high for many hours, the risk is too great. You discard the product and move on. Always document what happened, when, how long, what was done, who approved the decision. Scenario 2. You spot slime on a product during a quality check. Slime means bacteria, often Pseudomonas or Lactobacillus, which produce a mucilaginous layer. That product is rejected immediately and segregated. You then use the 5 whys to figure out what went wrong. Was the temperature too high? Was the humidity so high that the product became anaerobic and encouraged spoilage bacteria? Did the product sit too long? Did it arrive contaminated from the farm? Once you know the root cause, you fix it and document what you did. These corrective actions take time, but they protect your brand and your customers. How do you know if your storage system is actually working? You measure it. First, shelf life achieved versus target. You want to hit that 7-day target consistently. If you are consistently achieving 6 days, there is a problem. Maybe humidity is too low or temperature is too high. If you are achieving 8 days, great, but also investigate why. Maybe the product is better than expected, or maybe your testing is not catching early spoilage. Second, rejection rate. What percentage of product are you rejecting before shelf life end? If it is more than 2 or 3%, your preventive controls are not working well. Third, temperature compliance. Are you hitting the temperature spec 100% of the time? You will never be perfect. Equipment fails, doors get left open, but if you are missing the spec more than 2% of the time, your monitoring and corrective action system needs improvement. Fourth, microbiology. This is the most important. Test samples at shelf life end. Are you getting 0 Listeria, 0 E. coli? That is the goal. If you are finding pathogens, your storage is not safe, and you need to tighten control immediately. Fifth, consumer complaints. Track them. If you start getting complaints about slimy product or off odors, that is a signal that something is going wrong upstream in your storage. These KPIs together tell you whether your whole system is working or whether you need to make changes. Storage management is not just best practice, it is a regulatory requirement. In your HACCP plan, storage is almost always identified as a critical control point because it is where you control microbial multiplication. The hazard is Listeria or other pathogens growing and reaching unsafe levels by shelf life end. The control is temperature, keeping it at 4 degrees or below. The critical limit is the temperature you will not exceed and the time limit you will not extend. Your monitoring is daily temperature recording and periodic product testing. Your corrective action is what you do if temperature goes out of spec. And your verification is checking the logs monthly, calibrating thermometers quarterly, and doing a shelf life validation study once a year to confirm that your conditions still achieve safety. All of this is documented. If there is ever a recall or a regulatory inspection, you pull out your file and you show the inspector. Here is our HACCP plan that identifies storage as a CCP. Here is our daily monitoring log showing we controlled temperature. Here is our corrective action log showing what we did when something went wrong. Here are our calibration certificates proving our thermometer was accurate. Here is our shelf life validation study showing that the product was safe. That documentation is your proof that you are a competent, responsible food business. Let me highlight 4 common mistakes I see in food facilities. First, one-size-fits-all specifications. I walk into a cold room and ask, "What is your storage temperature?" And they say, 4 degrees for everything. But salads are different from fish, which is different from cheese. Each needs tailored conditions. Second, monitoring without recording. A staff member says, "I check the temperature every day, I do not need to write it down." But if there is ever a problem, you have no proof that you were monitoring and you have no data to analyze trends. Always write it down. Third, ignoring small deviations. The spec is 0 to 4 degrees. The thermometer reads 4.8, thinking, "Oh, it is close enough." But those small deviations compound, and by next week, you have bacteria multiplying much faster than your shelf life model predicted. Investigate every deviation. Fourth, only monitoring temperature. I have seen cold rooms with perfect temperature records, but products that still spoil because the humidity control failed or the compressor was cycling on and off, creating condensation. Monitor temperature, but also look at the product itself. Does it smell fresh? Does it have a good color? Is it slimy? Your senses catch problems that numbers alone might miss. Let me show you the money. If your salad greens are stored in an uncontrolled way, say, sitting in a warm loading dock or under bright lights, they will only last 3 days. 40% of what you produce spoils before it reaches the consumer. If you are processing 5 tons a week at €5 per kilogram, that is 25,000 euros per week of production. Losing 40% is 10,000 euros per week wasted. Over a year, that is €500,000. Now, if you implement proper storage, a dedicated cold room at 2 degrees, high humidity, dark, good ventilation, you achieve your 7-day shelf life target. Now only 2% spoils. That's same 5 tons a week, same price, but only 500 euros per week wasted instead of 10,000. Annual savings, 475,000 euros. That is not a small number. And beyond the money, there is the environmental impact. Less waste means less transport, less packaging, less landfill. Your brand reputation improves because customers consistently find fresh product on the shelf. So proper storage is not a cost. It is an investment that pays for itself many times over. Let's work through a real example. Your company has a new product, premium organic salad greens. They come from a local farm. They are high quality, but they are very perishable. Fresh salads are vulnerable to pathogenic bacteria like Listeria or E. coli, which can grow in the cold if given enough time. They are also vulnerable to moisture loss. The greens will wilt, and they can develop a slimy texture from spoilage bacteria. Your sales team wants to market these as a 7-day shelf life product, but currently they are only reliably fresh for 5 days. Your job is to figure out what storage conditions will let you achieve that 7-day target. You need to think about temperature. What temperature stops pathogens from growing but preserves the freshness of the greens? You need to think about humidity. The greens need moisture to stay crisp, but too much moisture and molds grow. You need to think about packaging. The current ventilated crate is good for air circulation but loses moisture. Could you add a film? You need to think about storage location. Are they sitting in a sunny loading dock or a climate-controlled cold room? By the end of this exercise, you will have a written specification that your team can follow. Let's think through the questions. First, temperature. You know from earlier sessions that pathogens like Listeria do not grow well below 4 degrees centigrade, but they can grow slowly even in the cold. The fresher produce literature says that 0 to 2 degrees is optimal for most greens, so we might set our target range at 0 to 4 degrees, with a tolerance of plus or minus 2 degrees. That means we aim for 0 to 4, but we accept 0 to 4, and if it goes below 0, we are getting freezer burn. If it goes above 6, we have a problem. Second, humidity. These are living leaves, and they are losing moisture constantly through transpiration. If the air is dry, they will wilt in days. If the air is humid, they stay plump. 90 to 95% RH is ideal. But if the humidity is that high and there is no air movement, condensation will form on the leaves and in the packaging, which is a perfect environment for mold. So high humidity and good ventilation are both necessary. Third, light. Chlorophyll, the green pigment, is sensitive to light. Under bright lights, it degrades and the leaves turn yellow or brown. So the greens should be stored in a dark, cool room, not under supermarket-style bright lighting. Here is the completed specification for the organic salad greens. Let me walk you through the reasoning. Storage temperature 0 to 4 degrees centigrade with a target of 2 degrees and tolerance of plus or minus 2 degrees. Why? Listeria, which is the pathogen of greatest concern in ready-to-eat produce, can grow slowly even at 4 degrees, but 2 degrees is even better. The tolerance allows for measurement error and minor fluctuations. Temperature rationale, This range minimizes pathogenic growth and preserves the crisp texture and nutrients. Humidity, 90 to 95%, because the greens are losing moisture constantly and need humid air to stay plump. But, critical point, we also need good air circulation, at least 10 air changes per hour. Without air movement, moisture condenses on the leaves and molds grow rapidly. Light, dark storage. Chlorophyll degrades under light, turning the greens brown. So no fluorescent overhead lights. A dedicated dark room is best. Packaging. We keep the ventilated crates because ventilation is essential. We do not wrap the crates in plastic film because that would trap moisture and promote mold. Shelf life. 7 days at these conditions. But, this is important, that assumes the conditions are maintained consistently. One cold chain break, 1 day in a warm truck, and all bets are off. Quality rejection criteria. If the greens show browning on more than 10% of the surface, if they are wilted, if they are slimy, they are rejected. If they smell off, sour, fermented, musty, rejected. Microbial. At day 7, if we test and find Listeria or E. coli, the product fails. A PC less than 10,000 per gram is acceptable. Safety information, these are raw. They come from a farm where contamination is possible. They must be separated from ready-to-eat products and from raw meat. FIFO, first in, first out. Use the oldest product first. In closing, remember 3 things. 1. Plan it. Before you store a single product, think it through. What does this product need? Write it down as a storage specification. Make it accessible to your team so everyone knows what is expected. 2. Monitor it. Do not assume things are fine. Measure temperature daily. Look at the product. Keep records. When something is out of spec, investigate and fix it immediately. 3. Improve it. Review your performance regularly. Are you hitting your targets? If not, why not? Use data to drive continuous improvement. At the end of the day, storage is not complex. It is about controlling 3 things: temperature, humidity, and time. Get those right, and your product stays safe and fresh. Get them wrong, and you waste product, you risk consumer health, and you damage your business. The choice is yours. Thank you.